Trig identities. In the old HL course, this used to be a month of stuff. Now they've boiled it down to 2 identities. So you'll be solving some equations, and sometimes you can clean it up. You can simplify it with identities. What's an identity? It's an equation that's always true no matter what the variables are. So for example, a really simple trig identity would be x equals x. This is true for all values of x. Interesting? No, but it is an identity. Okay? Now, a trig identity is an identity, so an equation that's always true, no matter what the variable is. So in this case, we're talking about the angle. So we've got 2 of them here. If you want to prove them, which you could be asked to do, they're based on some more fundamental trigonometry. Now the first one is based on this idea. All you have to remember is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. If I replace this, so if I think of this little triangle, this is opposite, this is my angle, this is 90 degrees, this is adjacent, this is hypotenuse, okay? So what does sine equal to? Opposite over hypotenuse. So this would be opposite over hypotenuse squared. Cosine would be equal to adjacent over hypotenuse squared, and 1 would be equal to 1. If I expand this, this is O squared over H squared plus A squared over H squared equals 1. O squared plus A squared over H squared equals 1. And opposite, we know that this is equal to what? H squared. Right? Technically, if I was doing what an official proof, which we don't have to do right now, we can't do equal to 1, equal to 1, equal to 1. We have to come to that conclusion. So I've worked on the left-hand side of the equation and come to the stating that it's equal to the right-hand side. So left side equals right side, therefore statement is true. That's a direct proof, it's called. There you go, some HL. Okay, tangent, same kind of deal. What I could do here is I can work on the right-hand side. Why? Because it looks more complicated, and I'll use that. So same deal here. Sine theta is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse, which is equal to opposite over hypotenuse times hypotenuse over adjacent. These cancel out, so that's opposite over adjacent, which is equal to tan theta, by definition. So right side equals left side, therefore statement is true. Ta-da! Okay? So those have just been proven to you, using some more fundamental ideas. How fun. Okay. Actually, I'm not sure why I'm erasing that, because that might be it, because that's all you need. What you need now is some examples. Woo! So these are examples of everything we've done so far. So, looking at some of these, okay? Write down the values of sine of 0. See, now this is the stuff. One is just about memorization, okay? The sine of 0, I don't care how you think about it. You can think of it as, I remember the graph, right? Or cosine. And you can go off that. Or you can use my little thing like this, where this is 1, 0, 0, 1, negative 1, 0, 0, negative 1, and all that jazz. And you know that sine is opposite over hypotenuse. Sorry, that's terrible. Cosine is equal to x over r, and tangent is equal to y over x. So if you have that, you can kind of figure it out. The sine of 0 is 0, cosine of 0 is 1. The sine of pi is 180 degrees, and the sine of that is 0. The cosine of pi over 2, that's 90 degrees, that's 0. And the sine of negative pi over 2, oh, did we do negatives? I don't think so. Negative pi over 2 would be negative 90 degrees, which would take you here. So what's the sine of that? Negative 1. And the cosine of negative pi would take you all the way over here. That's negative 180 degrees. And the cosine of that would be negative 1. The sine of 3 pi over 2 is 270 degrees, which takes you all the way to the bottom there. And that would be equal to negative 1. And the cosine of negative pi over 2 is again at the bottom, so the same exact area, and that would be equal to 0. And there you go. Notice how fast I did that. How did I do that? I'm looking at those graphs beside me. I've done this a lot too. It takes some practice. You will be a little slower, but you can get there. It's just reasoning it out. You do have to think. Sorry for the extra noise. Each of the following, find the solutions for everything from 0 to 720 degrees. Sine x equals 10 degrees, sine of 10 degrees. This is kind of interesting. I'm not going to do all of these because they are a little bit repetitive, I think, but just as an example. What you do have to remember is, again, this, like this, or you can visualize like this. How often does sine repeat? Okay, notice that sine of 10 degrees would be somewhere here in the first quadrant, and it would repeat in the next quadrant here. Or another way to think about it that I think is much better is this CAST, right? The sine ratio is the same in the first and second quadrant. How do I know that? CAST, positive in air, positive here. No good in the other two because they're negative. So if this is 10 degrees, by symmetry this is 10 degrees, so the other angle would have to be also, give you a moment, 170 degrees, because I'm always measuring from the positive x-axis, turning counterclockwise. So 170 degrees will work also. Now they say go all the way to 720 degrees. So I could go all the way around. Now I'm just adding 360s. So it'd be, if I add 360 to my 10 degrees, this is 370 degrees. And if I add another 360 to my 170, this is 360 plus 170, which is equal to 530 degrees. So that's one here, okay? You can work out the other ones like this, and you might say, hey, this one looks funny. Find the first one with the calculator. There's no other way around that because that's not a nice ratio. Okay, it's not one of your magical ratios that we've worked on. And then you can rebuild like I did. Find that first angle and then build from there. Okay? If it was in radians, you'd have to do all this work in radians. I would probably do it in degrees first and then convert. That's just me. So for example, B here, same kind of deal. 2 pi over 5. Yeah, I suppose it's just so much more work. You won't really get that on an IB exam because it's just so much more work. Same deal though. So 3 pi, by the way. So you can convert, oops. Stop that. You can convert that to degrees, convert this to degrees, and then kind of do all that work that we've just done above. Or you can kind of like think it through with angles. So for example, if I was working that one out, I would say the same kind of deal. It's sine again, so it's here and here are the same. So the first one is 2 pi over 5. So this one would be 2 pi over 5. So what would this angle be? It would be pi minus 2 pi over 5, which is equal to 3 pi over 5. So 3 pi over 5 is also good. So for that one, 3 pi over 5. And then I would add 2 pi's to those, which is 2 pi is 10 pi over 5. So 12 pi over 5 and 13 pi over 5. I think that's right. So it wasn't so bad. Good times. What else can we do here? Are there more? we're trying to keep this short. So not particularly. I'm going to let you think these through because there's nothing here that I find overly engaging. Hey, I'm missing some good questions here. I'm missing questions on trig functions. I'm going to let you work on these. I'm going to add one here, trig functions. So if I look, if I think real quickly here for trig identities, sorry, if it's something like this, how can I think of an easy one? Okay, I'll think of a really easy one. Sorry, it's not that interesting. No. Yes. Yes, sure. If I want to solve this equation, okay, first of all, even if you could just cancel out things, don't. Factor only. Factor, 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 because some number being equal to 0 is a possible answer. So for this one, what was I thinking of? Actually, here, it needs this. Okay, this is better. For this one, how can I solve something like this? Well, factor. Factor, factor, factor. So how do I solve this kind of equation? Cos x is factorable, and I'm left with this. Right? Now, if you would have divided both sides by cosine, you would have had cosine x disappear, and that would have been a problem. Let me explain. So if I factored it, big deal. So now we have two possibilities. Well, actually, first of all, sine x plus cosine squared x, I can simplify this using my trig identity. What's that equal to? If you memorize that, that's equal to 1. So I'm left with only this as a possibility. There you go. If I would have just canceled it out, if I would have divided both sides by cosine x, what would have happened is the possibility that cosine x equals 0 would have disappeared. Because what you would have in fact done is divided by 0, which is really bad in math. That's why you always factor. So that's a possible answer, although I'm not finished. So what can x be? Well, when is cosine x equal to 0? Again, I go back to this thing. If I don't have a calculator, because I could have a calculator and figure this out. But remember, cosine is x over your hypotenuse or your radius. So it's the x coordinate on here, 2, 3, 4. Hey, my circle's pretty good. So remember, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1, right? Like that. Why do I go to those? Because I know that's when a cosine x, it's one of these. So cosine is x over the radius, which is 1. So it'll be at 90 degrees, like that. And it'll also happen again at 270 degrees. So x could be 90 degrees or 270 degrees. And it depends if I would have stated, let's say it's 360 degrees like that. That's fine, I could have stopped, but to say it was like from 0 to 720, I would have had to add 360 to both those answers. Or if I would have said simply, the answer has to be between 0 and 180, then only one of those is possible, 90 degrees. It's the easiest way to do this. You can do it with this. When is cosine 0? It's here and here at 90 and 270, because that's 0, 90, 180, 360. So it's these two. Yep. Okay. There's a few questions there. I'll stop it. And